Alrighty, 9:15. We're going to cover a bunch of stuff over the next hour and 15 minutes. Specifically, I want to cover object orientation and do a little bit of a review over that. We're going to compare that to functional programming. We'll quickly dive into like what's a library and what are some of the libraries that are available to us. We're going to look over a new debugging tool called IPDB, and then we'll talk about the Beyond Tech today, which is something called imposter syndrome. With that, I'm going to go relatively quickly, but in the case that you have any questions, please feel free to slow me down. Raise your hand in the Zoom chat box if you have any questions. All right, so let's do a quick overview of object orientation. So we're inside of our code folder. Let's do, I'm going to make a directory, mkdir, make directory, called FP versus OOP. And you'll see that on the left-hand side over here, before it didn't exist, and now FP versus OOP actually shows up. Now let me jump into CD into OOP, FP, and then just press tab to change my directory from where I was into where I'm at right now, which is FP versus OOP. There's nothing inside of it. You can kind of tell because I'm clicking on this and nothing's happening. So I'm going to create a file called fp.py for functional programming. You'll see that it shows up, and the same thing for OOP. Let's do a review of object-oriented programming. So object-oriented programming is a way to, it's simply a way to program. It's a paradigm, a programming paradigm that has come into like a lot of popularity over like the past, I'd say, decade or two. There's going to be proponents of saying that functional programming is better than object-oriented programming, and other people who say object-oriented programming is better than functional programming. Based on what I see in the industry, I would say 90% of the code that I see written now, I'll be generous, 80% of the code that I see written now is written in an object-oriented way. And what that means is I have reusable classes that can do specific things. So let's say that we've got like a bank account. So let's say we got a class called account. What are some attributes that most bank accounts have? Let's call on Frankie F, because that's the name that I see here. Frankie, tell me what are some things that you would usually have inside of a bank account?
Like the account number? Or...
Sure. Okay, so we need to keep track of the account number. All right, what else can you like? So let's talk about two different things. One is like attributes of a bank account, and then functions of a bank account. So you said that some of these, we'll separate this into attributes. So there's an account number, maybe an account owner name, something like that. What else? Let's do one more.
How much money is in the account?
Routing number.
Okay, say routing number. I'm going to load those two together, and current balance. That's something that we need to keep track of. So these are attributes of your bank account. When you log into your bank account, there is a routing number for your bank account. There's an account number for your bank account. There's an account owner name and a current balance. What are some of the methods that we can do? And I'm not looking for like anything like grandiose. I'm just looking for what are the basic things that you can do with a bank account.
Transfer money.
You can withdraw.
Withdraw, or yeah.
Or you can deposit. And you can, I don't know, you can go to the ATM and say, get my current balance. So current balance. So these are some of the methods that a bank account can do. Let's say this is an account over here. They have certain attributes and they have certain methods. What I'm going to do here is I'm going to create a new, I'm going to create a class called account. This is object-oriented programming. The moment you see something with class over here, you're talking about object orientation. This is reusable code that I can use over and over and over again. So we said a little bit earlier that an account, some of the attributes are a routing number, there's an account number, there's a current owner name, and there's an account balance. So if I were to create a new account, some of these things I would automatically be able to pass in. Other things I would need to like get. So some of the attributes, routing number, you don't pass that in when you create an account. Like your bank already has a routing number. It's already fixed to that particular bank. That's not something you would pass in. So that's not something that would go in the initialize method on line 13. But you can pass in the account owner name, and you can pass in current balance. Or let's say opening balance, because that's when you first create your bank account, it comes with an opening balance. What I'm going to do now is I'm going to talk about something called instance variables versus local variables. So within this particular class account, I'm probably going to reference the account owner name, and I'm probably going to account for, know what the opening balance is at all times. So what I'm going to do is I'm going to do self.account owner name is equal to account owner name. And then self.balance is equal to opening balance. And that's where I'm just going to start. I'm going to say John's account is going to be an instance of account, Jonathan Young. And my opening balance is, let's say I'm a real baller. I got 500 G's in the bank account. At this particular point, I can do stuff like print John's account dot account owner name, and the same thing for my balance. Let me run this. Again, let me just scroll down a little bit. So I've got a class called account. This is some reusable class within Python. There's an initialize method, meaning I'm going to create an instance of an account. So think about Bank of America or a Chase Bank. They probably have something like this at the very, that they created a very long time ago called account. Checking account, savings account. In each one of those things, you can pass in certain attributes. You can pass in who owns it and the opening balance that you have. Now, what I've got here is on line 14 is I've created an instance variable called self.accountOwnerName, and that's going to be set to what I pass in on line 13, which is account owner name. Now, I've also got self.balance on line 15, and that's going to be equal to the opening balance. Let's just see if we can access these two outside of the class. I'm just going to run Python oop.py, and I've got my account name, my account owner name, and my balance over here. Jonathan Young, we've got 500K inside the bank. The power behind having these self dot is that once I initialize the class, once I create a new bank account for Jonathan Young and the opening balance is 500K, I now can keep track of that person's name and the balance at all times. So let's say that I have a method. This is where my methods are going to start coming into play. There's a print current balance. Let's create that method. Print current balance. I'm just going to print. I think I have self.account owner name as a balance of self.balance in their account. So I want to make this as reusable as possible. I've got a method called print current balance. Again, if you walk up to the ATM, you want to get your current balance, and then they can print that for you on a receipt. So that method underneath the hood is basically going to say, I'm going to print out to the screen, this particular person has a balance of this balance in their account. I'm not going to go with pronouns here because I just want the most reusable, so I'm just going to use the generic pronoun up there. So I've got self.account owner name, and you'll notice that self.account owner name was created right at the beginning of initializing my account on line number 20 over here. And then I can reference that everywhere else that this is referenced. So as long as I put self.account owner name, I have access to this. This is an instance variable on the left side of the equal sign. This is a local variable. The local variable only lives within the context of where it's defined, where it's used and defined. So it only exists between lines 13 and 15. It does not exist in line 18. So let's get rid of lines number 21 and 22, and I'm just going to run John's account.print current balance, and I'm going to invoke the method over here and see what happens. All right, so we've got our class up there. I create a new account, John Young, got, let's just say $50 because I'm going to say 500,000 too many times. And I'm just going to say print current balance. So run, press up for Python OOP.py. And it says Jonathan Young has a balance of $50 in their account. I'm going to put a $sign in the front so it's formatted more pretty. Jonathan Young has a balance of $50 in their account. Let's go back and talk a little bit again about instance variables versus local variables. Instance variables begin with self dot. If I get rid of this and I try to run it again, hey, because I created it, account owner name on line 14, I passed it in, I should be able to access it, right? It blows up on line number 18. It says account owner name is not defined. So despite passing it in on line 13 and using it on line 14 over here, again, local variables only exist within the context of which they're defined. Since it only exists within the init function, it only exists between lines 13 through 15, meaning that it's not available to use on lines 17 and 18. And that's where we want to use something called an instance variable. The moment I do the self dot on line 14, I can use it outside of that method. You'll notice that all of these also begin with self because it's a instance method within the class. So once you put in the self in the front, I also have access to the self dot. Are there any questions on that before we move forward to the next thing?
I got one quick question on that, John.
Go ahead.
Yeah, so you have to use self dot to access the init, the instance variable. So if you, for instance, had 3 or 4 other class methods down there, like change current balance or whatever, how do you share variables? Like if you created a variable within print current balance and you want to share it with another method, or is that bad practice? Do you always just use init variables?
That's a good question. So just to repeat your question so I understand. So I would say 9 times out of 10, you would initialize all the shared instance variables that you want to use across all the methods at the very beginning. So I'm probably going to use account owner name. I'm probably going to use balance, and I'm going to put that up here at the very top. But you're saying that what if I have something like self some other variable equals, I don't know, like 1, 2, 3 or something like that. And it's only going to, like, once I define it on line 18 and I call print current balance, to answer your question, James, the moment I write this and I call print current balance, this is available everywhere else. If I don't call print current balance, it doesn't exist.
Okay.
Because I'm initializing it, this particular account on line 21 here, all of these are available right away because I initialized it. But some other variable won't actually exist until I call print current balance. So let's say that I want to do print John's account dot some other variable. Watch what happens. This is going to blow up because account object has no attribute called some other variable, which is strange because I have access to account owner name. Let's try running this. You'll see that Jonathan Young shows up because that executes as a line as a result of line number 22. And then it blows up on line 23 because some other variable doesn't exist. But if I were to move this simply 23 down to below print current balance, I will have Jonathan Young. Jonathan Young has a balance of $50 in their account, and then 1, 2, 3 shows up because I called this particular method before I accessed it. Cool. Let's continue on. Let me go back to the original. And okay, so we talked about current balance. It's done. We talked about the account owner name. We got rid of that. We got rid of the print current balance. All right, there's some things like routing number and account number that we should probably talk about. So account number. Let's talk about this. Do you think let's start with routing number. Does routing number change ever?
No.
No.
No. I'm sure it's possible that it would change, but imagine if something as large as Chase Bank decided to change their routing number, like hundreds of millions of people would be affected. So that's what we call a constant, something that doesn't change. So we've got our routing number. I'm going to set that outside of the class because that's not unique to just this particular account. I could put it within the class. It's up to you. But I'm going to put it in all caps just as a notice to myself that this is a constant. This is something that won't change. I don't know what the actual routing number of Chase is. Let me Google it. chase routing number. I'm on another screen. Don't worry. Let's take a look at this. And I'm just going to set that equal to this. This is the routing number of chase. This is something that was defined early on. It probably won't change. I know they have routing numbers per state, but let's just pretend that there's one routing number for all of Chase Bank. All right. So if I ever want to have access to routing number, let's take a look. Do I have access to routing number? I don't know. Let's do def print routing number. I don't know if I have access to this, but routing number. Let's see if this works. John's account dot print routing number. Let me clear the screen down over at the bottom. All right, it looks like it does work. So what you'll notice is I created a new method called routing number, and it's I just set it equal to print the routing number, all caps. I've defined it up here because that's something that's a constant. It's all in caps because it's a constant, something that doesn't change. So I've accounted for the routing number. Maybe we have to generate our account number now. So let's, I don't know how to actually do this. Like our account number is something that you choose. Is that something the bank chooses? Like what do you think? How should we implement our bank account class here?
Routing number should be inherited for everybody.
That is, so I want to be careful about the choice of words because have we talked about inheritance yet?
Uh,
I don't think so, right?
We have
So
not.
inheritance is a very specific thing, so I want to be careful with the choice of words. So routing number is available to everyone. It's not inherited to everyone, but it's available to everyone. But account number, is that something we should generate? Is that something we should pass in?
account number would be tailored to the individual user.
Yeah, it's not something that you can't go to the bank and choose your account number. So what I'm going to do is I'm going to create a new method called self.generate account number. I'm going to run that second. All right, maybe I'll run it first. So whenever I create a new instance of the account class, on line number 12 here, I'm going to generate an account number right away. So let's say that I'm going to do def generate account number. It's going to be self because it's an instance method. And I'm just going to say self.account number is equal to, I don't know, I had to figure out how to randomly generate a 8-digit number Python. How to generate random number with specific length? I don't know. Random 3, random 5. Oh, okay. Oh, okay. That's not the real. That's the question. Sorry, this is the number down over here. To get a random 3-digit number, it's just going to be from random import randint and then randint between 100 and 999 inclusive at both ends. And you might be wondering what's going on here. And that kind of leads us into our Python library challenge, not challenge. Lesson. All right, so from random, import randint, and let's dump this down over here. Let me fix up some spacing so that we all understand what's going on. Let's just say that the random is going to be 8 digits, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Has a balance of this. Routing number. Let's print account numbers. I'll explain this in just a second. Let me just get this done. Cool. Cool. All right. I just did a lot of code. Let me walk through what's going on. We'll talk about this in just a second. We've got our routing number, this is a constant. This is something that doesn't change. Again, your bank has a routing account number, and that doesn't change. We've got our account over here. We've talked about this a little bit beforehand. We're going to pass in, whenever we create a new account, like we are on line number 27, you're going to pass in the owner name. That's something that you have to assign when you're signing up for your bank account. And you have to have an opening deposit or of a certain amount. So that's your opening balance. I probably will change this. Let's change this to something else. Opening deposit. That's a little bit more accurate. So whenever I create a new bank account, I walk into Chase, I tell them my name, I give them 500 bucks in cash. That's my opening deposit. At the very beginning, when they first create my account, the first thing that they're going to do is they're going to generate an account number, one that hasn't been used before. And I know we're not really accounting for if it's been used before or not, but what I'm doing here is kind of what James mentioned earlier. I'm setting an instance variable called self.account number equal to some random integer between 10 billion or whatever this is and a bunch of nines. So it's just some random 8-digit number. Once this is called on line 14, self.account number is available everywhere else within the instance of the class. Again, number 14, line 14, I generate the account number and I have account number equal to this thing over here. I've got a method called print current balance because that's something that you see at the ATM. This person has a balance of whatever this balance is. And then finally, I have print account numbers. This is a method that we probably need very often when we fill out bank information online. It's like, what's your routing number? What's your account number? So that we can do direct deposits or something. So I've got a method called print account numbers. And I've got print F, this is for formatted string. Routing number is equal to this interpolated routing number from line 10. And the account number is self.account number. Let's see if this one works. Oh my God. Something happened.
Your second F string in the very bottom one is missing a curly brace.
Missing a curly brace right there. Thank you. Let's run it one more time. Okay, so we've got we ran line 28, print current balance, that's this over here, and we have print account numbers. So we have routing number is equal to this, and then the account number is equal to that. So this is my randomly generated account number that I generated on line 19 as a result of line 14 right over here. Does that make sense to everybody?
John,
Yep.
if you run this again, do you get a new account number, and how do you like store it as yours after you generate it the first time?
Good question. If I run it again, I can run it a bunch of times, you'll see that the number changes every single time that I actually change this. So what we're doing right now is we're writing stuff inside of our computer's memory. But when you go to your actual bank account, this will actually save, this eventually will lead to a database. And once it reads into a database, you'll have like a dedicated number that will stick with you. Right now, the official term is your data is not persistent, meaning it's not actually being written into a database, so it changes every time that you run this particular file. But eventually it'll be, your data will be persistent, meaning it's actually saved within a database. Let's talk about line number 8. From random, import randint. And then you can kind of see, if I just double click on randint and I do Command D again, on line 19, I'm using random integer. This is what's called a Python library. So what I'm doing here on line number 8 is I am saying from the random library, import the random integer class. So underneath the hood of Python, somebody created a random library, and then within there, they have a random int class that takes in 2 arguments, the first one being some number and the second one being some other number. This is a little bit of magic, but it's also known as a Python library. A Python library is basically just thousands of lines of code. Somebody wrote this ahead of time so that you don't have to do it. So let's take a look at the Python random library code. If you want, you can read through each one of, like the code is written somewhere. I don't actually know exactly where it's hosted, but you can kind of jump over here. If I just say Python random library, the first thing that shows up is the official Python documents. I click on this, and over here it basically tells you like this module implements pseudo-random number generators for various distributions. And you can read through all of this, but essentially what people are trying to do is they are trying to get like a bunch of functions like how do I actually solve the thing that I want to do? There are a lot of numbers over here. There's a lot of numbers, there's a lot of methods that are available, but I want to just choose a random, I want to get a method that does, gets me a random integer. So when I do random.randint, A and B, it returns a random integer n such that A is less than or equal to n, which means that if I pass in 1, it's going to return some random number. 1 is going to be less than or equal to n, which is going to be less than or equal to b. So if I give 1 and 5, they're going to return some number like 3 or 4, which is going to be 1 is less than 3 or 4, which is less than 5. So again, Python libraries, it's just thousands of lines of code that somebody wrote ahead of time to make your life as a developer easier. Because otherwise you would have to generate your own random number that's 8 digits long, and that code is much longer than just bringing it in on line 19 like this. There are other libraries that we're going to be using as we get more and more advanced with Python. Requests we're going to see pretty often. If you want to move more towards like data science, NumPy and SciPy and pandas and plotlib and all that kind of stuff, that will come into play. So that all you have to do is just do stuff like import this from this library, import some class, and then you have access to a lot of other things. This is just one of those things. Same thing also exists within JavaScript. The one that we're going to be using a little bit later is React. So underneath the hood of React, which is built by Facebook, let me just jump over to GitHub. Pretty much everything is written in React. So if you just go to venmo.com, we did just rewrite this. This entire thing is written in React. The entire front end is written in React. So it's just a framework. It's a framework, which just means, again, it's hundreds of libraries, which is already hundreds of thousands of lines of code that someone wrote ahead of time to make your life easier. We'll get much more into this as we advance in our skills. But React is a framework, which is a library of libraries, and it's just thousands. I think at this point, millions of lines of code, which make your job developing easier. There's a lot of code that powers Venmo.com, and like each one of these buttons has to be specifically placed. There's a particular iconography. When I hover over this, this stuff starts dropping down. How it works, trips and ticks. And what you'll notice is that each one of these colors also changes based on where I am. So it's all this stuff where it's like, imagine writing this in pure JavaScript. It's a giant disaster. Like you're talking, millions of lines of code. That's exactly what it is. But through React and through all these libraries that are built in, kind of like what you're seeing here with randint, I can hover on this. It keeps, like JavaScript and React will keep track of my mouse movements. When I hover over how it works, it changes the background to blue. When I hover over tips and tricks, it turns it into teal, so on and so forth. We're going to learn how to use all of these things once we get over to React, but I'm just trying to introduce the concept. A library, most things that you want to do, there's probably a library that already does it and makes your life a lot easier. Going back to our really rinky-dink programs, let's talk about, so we took care of account number. Let's talk about these two methods called withdraw and deposit. All right, so let's go back to who was helping me a little earlier. I think it was Frankie. Yeah. All right, tell me what I need to do if I want to deposit and withdraw money. What are some of those methods? What's the method going to look like?
So you're going to create another method. So define, you can call it withdraw or deposit. Yeah. Okay. So when you're depositing, obviously you're going to need your opening deposit and then add whatever amount you're depositing.
All right. So amount to deposit. And you said I need the opening deposit. So when I create my account, it starts with 50 bucks. And my balance I have access to now. How do I use this instance variable in here to change my existing balance?
Would it be self.opening deposit?
Nope.
Nope.
Remember, so opening deposit only exists inside the init function over here. So I'm passing it as a variable, as an argument opening deposit, and that's this 50 down over here. So I'm going to take this 50, it's going to come in here, it's going to go over to line 13. So opening deposit is actually 50 in this case. And now I'm setting self.balance
Balance.
to 50.
Okay. So self.balance.
Yep. That's it. That's all it is.
Yeah.
So let's repeat what we did. So we're creating our bank account class over here. And I have a method called deposit. That's something that you must have access to as a bank account. So I'm going to deposit a certain amount of money, which is going to update the current balance. So this current balance over here, I set it initially equal to the opening deposit. So let's take a look. Let me comment these two lines out for right now. And I'm just going to do John's account dot deposit, I don't know, 50. I'm just going to do this a bunch of times. I'm going to deposit different amounts of money, 25, 31, 74. And I'm going to print the current balance at the very beginning. I'm also going to put it at the very end. I can copy an entire line by clicking on it, Command C, and then clicking anywhere, Command V, it'll paste the line above where you clicked. Let's run through this. How am I doing on time? 45 minutes. All right, so Jonathan Young has a balance of $50 in their account. That's this line over here. I instantiated a new instance of the account class with my name and my opening deposit of 50 bucks. When I call print current balance, it reads self.account owner name, which is on line 11, and then it has a balance of self.balance. And this is something that will change over time. Then I deposited 50, 25, 31, 42, $74, and then I said, hey, print this again. So each time that this runs, it's basically saying self.balance, this instance variable that's shared within every single method of this particular class. I'm going to add on the amount to deposit. And what you'll see at the very bottom is that it did keep track of it. It added 50 to 50 plus 25 plus 31 plus 74, and that's $230 over here. And then finally, we're going to do something similar with the withdrawal.
So you just define withdraw, and then it would be an amount to withdraw. And then you're going to subtract it instead of that. Yeah.
Yep. That's pretty much it. All right. So the idea here behind object-oriented programming, let me see what have I done? I have done this. I just have two things left to cover. The idea behind object-oriented programming is that you want to keep track, okay, so again, object-oriented programming is just a programming paradigm that people follow. There's also another one called functional programming. It's another paradigm that people follow. You can accomplish the exact same thing that you want over here, that you run within object orientation inside of functional programming. It just takes a little bit more time to write. So in object-oriented programming, you have the concept of a class. When I create this class on line 30, when I create an instance of this class called John's account, like this account is now saved into my computer's memory system whenever I run this particular program. It keeps track of things like account owner name and balance, and it keeps track of account number. And then when I try to withdraw or deposit money, it keeps track of all of that for me. So it's really simple in the sense that it's like, this is how we usually think. We think of things as like nouns that have adjectives or attributes to them, with also, they also have methods and verbs that they can actually do. So it's kind of like, this is the way that we usually think of the world, but there's another way of writing the exact same thing using functional programming. So with that, I'm going to just copy this over here. Let's see. Now, inside of functional programming, this is stuff that we've done like pretty much all until like right now, which is basically, I have a function that takes in some arguments and then returns other arguments. That's it. But it doesn't keep track of state. If you change the balance, you have to keep track of that outside. Versus when I have object-oriented programming and I want to change the balance, I'm going to keep track of that on the inside. So let's take a look at all this. I'm just going to copy this. I'm going to use this as a reference point for myself, and I'm going to translate this entire thing. And don't worry, I will also copy and paste this inside of your channel, so you don't have to keep track of it. I'm just going to get rid of all this and just comment this out for right now. I need to keep track of, I can still keep this routing number here. But again, with functional programming, I can't actually keep track of owner name and opening deposit and balance and the account number. I don't actually keep track of that within a class. It's just a method that takes in one argument and then returns out another argument. So let's just say that I have an account. Let's say it's John's account is equal to, let's say the account owner name is equal to Jonathan Young. Same thing as before. I'm just going to say balance is equal to 50. And that is it. So if you take a look down over here on line number 40, I created an instance of an account with Jonathan Young and 50. And let's say I want to just do this first thing of print current balance, which is going to print the, this person has a balance of XYZ inside of their account. If I wanted to do something called print current balance, it would look a little something like this. Let me split the screen side by side so you can see them a little bit more clearly. Hopefully clearly. All right, so let's take a look at this. I'm just trying to do this first bit. So I instantiated on line 30 on the object-oriented side. I have an account with the name of Jonathan Young. It takes an initial deposit of $50. I'm going to save the balance as their opening deposit over here. On the functional programming side, there is no saving anything within memory. I take one object, I pass it through a function, and then that's it. So if I just want to print the current balance, I have to take an entire account object, which means that I have to have some sort of data structure to actually store this particular object. So what I'm going to do is I'm going to have John's account. It's going to equal a dictionary or a hash or an object in JavaScript. It's just going to be these curly braces where the account owner name is going to be this and the balance is going to equal 50. Then I'm going to run print current balance. That's this over here. And then it's going to take in John's account. What you'll notice here is that the account object, John's account, has the ability to print current balance. But on the functional programming side, print balance takes in John's account. And from there, it'll print out the account owner name. Let's run Python fp.py. Jonathan Young has an account balance of $50 in their account. Let me try doing the exact same thing over here. I'm going to make this a little smaller. Is this still visible for people? Because it's too small. Good? Okay. So I'm just running lines 30 and 31, functional programming.fp. So that's the right side of my screen, and then OOP, the left side of my screen. You'll notice that they do the exact same thing. But this is where this is where things actually get a little bit more interesting. I'm going to import the time module. Sorry about the sirens in the background. Cool. All right, so what I'm going to do is I've imported time, which is a Python library. Again, I'm bringing in a bunch of code that's available to me using time here. I'm going to create a variable called start time. And there's a method on time called just time, which is going to keep track of when you started. And I'm just going to do, at the very end, I'm going to create the start time. I'm going to run through my program. And then I'm going to print the time of what's the current time minus the start time and how many seconds did that take. Same thing over here. I just did the exact same thing. What you'll notice about object-oriented programming is it took 5.48 seconds. Like, I don't know, these are probably microseconds or something. When I jump into the FP, you'll notice that there is a huge difference in just performance. 5 seconds versus 3 seconds. So this one is 2 seconds slower, so over 50% slower using object-oriented programming. The reason behind that is I'm loading this entire object into memory, and this entire object gets to keep track of like, oh, this, I have to keep track of account owner name, I have to keep track of balance, and then whenever it's updated, I also need to keep track of that. So object-oriented programming is faster to develop but slower to execute. Functional programming is the opposite. It is slower to write, but it is faster to execute. Are there any questions on this?
Can you repeat that one more time? I just actually want to write that down.
Sure. So this is all in your curriculum for today. So object-oriented programming is slower to execute, so it's slower to run, but it's easier to write. So you can think of this as like, I'm going to go to, let's say I'm developing something at, let's say I'm developing stuff at Venmo. I can tell you that 99 out of 100 companies will write their code in object-oriented programming because they like to have stuff that's reusable, that their developers can come on very quickly and understand what all the methods are and all the instance variables. This is just easier to kind of keep track of. This is more, I feel like, how people think. And for a company like Venmo, this is perfectly fine. We don't need to worry about like every single microsecond. So this is like kind of like good enough programming, and this is 99 out of 100 companies. On the right side, you have functional programming. This will take a lot longer to write all your functions out, but it'll be much faster to run. And this is for stuff like high frequency trading. So if you're talking about like Robinhood, or like if you're talking about Amazon, where they have to worry about, you know, millions of hits a minute, you know, that's when you want to use functional programming because it's just that much faster. This one literally takes in an object that you pass it, and it just does one thing and it exits. That's all it does. I'm going to just generate the deposit and the withdrawal over here. And I'll just show you the exact same thing. So let's do, so we're going to print the current balance. We took care of that. And I'm just going to deposit a certain amount of money. And then I'm going to print the current balance again. All right, so again, I'm just going to run the start time. I'm going to instantiate a new John's account. I'm going to print the current balance, deposit 50 bucks, and then print the current balance again. I'm going to do the exact same thing over here. Deposit, account, amount to deposit. And then it's going to be account at balance is going to do plus equals amount to deposit and then return account. But you'll also need to start time, print current balance, deposit, John's account, equal deposit, John's account, and 50, and then the same thing. So these two things are equivalent on the left and on the right. I'm going to start the timer at the same time. I'm going to create an instance of this particular account. In one way, it's written in an object-oriented format, and the other one is written as a functional programming. It's just a dictionary over here. I'm going to print the account balance right away. I'm going to deposit 50 bucks, and then I'm going to print the current balance again. What you'll notice over here, though, because functional programming doesn't keep track of state, it doesn't keep track of your account, you're going to pass in the entire account. It's going to update one particular field, and it's going to return the newly updated account, and you on the outside need to keep track that that is changed. So I need to overwrite the original with the return value of this deposit over here. But you'll see like a pretty stark difference in runtimes. So I'm going to run first the object-oriented programming one. It takes 5.1 seconds. If I run the functional programming one, it takes 3.98. So one is 20% faster than the other one, and that's great if you're talking about like very, very like performant things. So if you're talking about game development where you need to worry about frames per second, if you're talking about Amazon where they have, you know, millions of hits a second probably, functional programming is probably very useful, but this is way easier in my opinion to read and to understand. And this will work for you 99 times out of 100. Any questions on object-oriented programming? I'm probably going to go over today, just a heads up. Let me cover IPDB real quick, and then we'll take a break, and then we'll come back and we'll do the Beyond Tech. Let's say that I want to go inside of my object-oriented programming file, and I want to take a look at let's say that I want to take a look at, you know, what is amount to deposit and what is self.balance. I want to have a breakpoint within my code, because oftentimes, like when you're running through your like loops over and over again, you're like, I wish I had something available to me where I could stop in the middle and take a look around. So with that, let's take a look at something called IPDB. Let me create a new file. I'm just going to save it in here called IPDB example.py. And I'm just going to say, create this method. Where's my mouse? There it is. All right, let's take a look. Import IPDB. So I'm importing the entire library. I could do two things. Like I said a little bit earlier, I can do IPDB.setTrace, and I can this will actually execute the code from the IPDB library. The other thing I could do, so these two are identical. These two things are identical. You can do either one. You can either bring in the entire library and then call the specific method, or from the library, import the method. That's what I'm doing over here. I'm going to keep the original because that was part of the write-up for today. And let's take a look at what happens. First things first, you're going to have to run pip install IPDB, because this is a library, and pip installs libraries for you. Once I run through that, which I already have, I'm going to clear the screen. I'm just going to run Python IPDB example.py. Oh, whoops, that didn't work. Install IPDB. All right, so I pip installed it, which means I said, hey, pip install the library called IPDB so that I have access to it. Let me clear the screen. And then run Python IPDB example. What you're going to notice is when I run this particular code, it stops at line number 4. So this is very useful within like running loops and you don't know exactly what's going on over here. It stops at line number 4, and I can evaluate everything that's around me. So it's like, what is first name? All right, so it looks like first name is John. So I'm stuck here. I'm just like, I'm just hanging out right over here. And the reason why first name is John, again, I've got say hello, it passes in first name, I'm passing in John, and it stops on line 4. So I'm fully at line 4. I haven't hit line 5 yet, and I can evaluate everything that's going around here. If I want to, if I'm pleased now, I know what first name is, I can just go exit, and then it'll actually run through everything for the rest of the, it'll run through everything. Let's take a look at a similar example. If I were to want to run that with a loop, let me just comment this out. I don't need this. So over here in this particular example, I've got age equals 12, and I've got a while loop. So while age is less than 21, I'm going to set the trace over here, which means I'm going to add a breakpoint where I'm able to look at everything. And it's going to print out, you're not old enough, you're only something age years old, come back when you're older, and I'm going to add +1. If I get rid of this over here, and I just run Python IPDB, it says it runs through everything. You're only 12 years old, 13 years old, 14, 15, 16, all the way up to 20, come back when you're older. So if I wanted to actually stop in the middle of a loop, what I can do is just throw this IPDB over here, run through it, And the very first time it gets through, I can take a look at age. Age is 12, so I know I'm within the very first iteration of my loop. Cool. I'm okay with this. I don't really need anything. I'm just going to type in N to go through the next iteration. So N is for next. You'll notice that this prints out. You're only 12 years old. Come back when you're older. Type in age. I don't know why that. Oh, sorry. Next is for next line. So before, you can see I was stopped at, like, I stopped right at line 10. And next is when I type in N to go to the next line, I can keep moving through like this. And then the second time through, I'm on line number 9 again, because this is a while loop. Keep going N, and I can take a look at age now. It's going to be 13, and I think there's a way to like step through a bunch of the. There's a way to step through. Let me grab this link. There's a way to step through all of your different commands using IPDB. So I just did N for next line. If I wanted to step, it would be S. If I wanted to return, or if I wanted to run, if I just wanted to continue, or just like, yeah, all of these are available for you within the IPDB. If you want to exit, it's just exit like this. So if I wanted to run through it, and I just said age, the first time through is going to be 12. If I just type in C for continue, it runs through the second iteration. So when I take a look at age now, it's 13. And these are all like, these tools, this particular debugging tool is particularly useful when you're stuck within a loop and you don't know what's going on. Cool. Any questions on the content that I've covered today? Object-oriented programming, the review, IPDB, Python libraries, anything. Good. All right, let's take a 5-minute break. We'll be back at 10:13, and then we'll get started on Beyond Tech.